Hi, welcome to another edition of Numero Studio. In this video, we will talk about tautologies, contradictions, logical equivalence, and fallacies. Let's begin by constructing the truth table of this compound statement. Because we only have two propositions P and Q, we have these four possible combinations. We start with if P, then Q. Next, the negations of P and Q columns. Then, if not Q, then not P. And finally, the biconditional of these two columns. Notice that the statement is always true regardless of the truth values of the propositions it contains. This is an example of a tautology. Next, let's construct the truth table of this compound proposition. We begin with the conjunction P and Q, the negation of P, and finally, the conjunction of the previous two columns. We are showing that it is always false regardless of the truth value of the propositions it contains. This is an example of a contradiction. And by the way, a proposition that is neither a tautology nor a contradiction is called a contingency. Two mathematical statements are logically equivalent if the final output of their truth tables are exactly the same. We use 3 bars to denote logical equivalence. P is logically equivalent to Q if and only if they are biconditional. As in the case of the first table we constructed earlier, notice that the conditional and its contrapositive have exactly the same final output. Hence, we say that they are logically equivalent. Using the truth table, can you show that the converse of a conditional is logically equivalent with its inverse? Now, let's talk about fallacies. Fallacies are invalid statements due to faulty or deceptive reasoning. Assuming if P, then not Q, there are some erroneous conclusions that may be derived by using the fallacy of the converse and the fallacy of the inverse. Say, we are given the conditional of the given propositions. If it is raining, then the ground is wet. What if the ground is indeed wet? Can we conclude that it is raining? This is a false conclusion. The ground can be wet due to reasons other than raining, like some pipe leaking, someone washing nearby, and others. This is called the fallacy of the converse. We cannot use the conclusion to affirm the truth of the hypothesis. What if we are given the same conditional? If it is raining, then the ground is wet. Now, what if it is not raining? Is it safe to say that the ground is not wet? This is again a false conclusion. Even if it is not raining, the ground could still be wet for reasons we already mentioned earlier. This is the fallacy of the inverse. The negation of the hypothesis does not mean the conclusion is false. There are other fallacies that are a result of faulty use of reasoning, such as these, and they will be covered in more detail in a separate material. I hope you learned the difference between a tautology and a contradiction, how to use the truth table to show logical equivalence, and how deceptive reasoning can result to invalid statements like fallacies. That's it for this video. Don't forget to subscribe and get notified for the next videos. I'll see you in the next one.